Welcome back to the Deep Dive. Today we're taking a trip back to 1985. We've got a stack of original source material, mostly from tech news, in February of that year.
And we're going to use it to really understand the foundational chaos of modern computing.
Exactly. We are plunging into a world that was just defined by this cutthroat competition, incredible technological compromises, and, frankly, some absolutely shocking crisis.
It really was the Wild West era of personal computers. I mean, if you just look at the headlines from that one month, it's everything.
Everything.
You've got these massive IBM lawsuits trying to just strangle the clone market before it can even get started.
Right. And then you have Apple, on the other hand, basically admitting that their revolutionary Macintosh was, and I'm quoting here, dreadfully slow.
And Amstrad. Amstrad was trying to kickstart a whole business revolution with a piece of hardware that would, let's be honest, it was fundamentally broken from the start.
Our mission today is to give you the blueprint for how this specific chaos, this whole mess of competing standards and legal threats, ultimately paves a road toward the PC dominance that we know today.
Yeah, we want to show you the precise technical decisions, the corporate battles that really define the future we're living in now.
And we absolutely have to start with the cost. I don't think you can grasp any of this without understanding the money involved.
Not at all. Without the context of inflation, you just can't get your head around the decisions people were making. I mean, even for what was considered budget technology, you realize computing was. It was an elite sport.
Let's anchor this with Alan Sugar's big move. The Amstrad 3-inch disk drive unit. Amstrad was chasing the mass market, right?
Right.
Trying to deliver a cheap plug-and-play business machine.
That was the dream.
The unit itself cost 199 pounds.
Yeah.
199 pounds in 1985. That sounds like a few hundred quid today, maybe a decent monitor or something.
Not even close. It's so easy to misjudge that.
Yeah.
When you adjust for inflation, that 199 package is roughly equivalent to spending 800 pounds today.
800 pounds?
800 pounds, just for the disk drive unit and its controller.
So you're telling me you're buying a peripheral that costs the same as a pretty good modern laptop and you're just bolting it onto your existing computer?
Exactly. And that's just to get in the door.
Because if you were a serious user, that was only the entry fee, wasn't it? Amsoft, which was Amstrad's software arm, was pushing the business side hard.
They had to. If you wanted the word processor, which they describe as WordStar quality, or the database, or the spreadsheet, each one of those was £49.95.
Okay, so another 50 quid each.
Which is now around 200 pounds today per application.
Wow.
So if you needed all three to set up a basic small office, the word processor, database, and spreadsheet, you were shelling out another 600 pounds in today's money.
So we're at 800 pounds for the drive, another 600 pounds for the software. We're already at 1,400 pounds.
For 3 pieces of basic productivity software. And it gets steeper. If you needed to manage money, the full accounting suite.
Sales ledger, stock control, invoicing.
That was bundled for £99.95.
So another 100 quid, which is
approximately 400 pounds today, just for that one bundle.
So to recap here, you're looking at an entry barrier of 800 pounds for the drive, plus another 1,000 pounds or more for the core software.
It was an enormous investment, and that's what frames this whole discussion. Every hardware compromise, every software bug wasn't just an annoyance. It was a massive blow to the user who had just spent thousands of today's pounds to get started.
Which sets the stage perfectly for our first deep dive. The Amstrad Drive Dilemma. Amstrad promised this affordable CPM business platform.
The dream.
But a single critical technical decision, or maybe it's a limitation, made that promise basically impossible to deliver.
Exactly. And on the surface, they got the plug-in-and-go philosophy right. The package looked good.
What did you get in the box?
You got the 3-inch disk drive, the controller, the cable, and a bunch of bundled software, including CPM itself, DR logo, some utilities.
And they even thought about the design, didn't they?
They did. They made the separate drive unit and the controller cartridge match the main computer's dark gray color scheme. For the time, that was a remarkable move toward, integrated industrial design.
And the setup was pretty standard for the era. You plugged a cartridge with the controller ROM into a socket on the back, then you connect the drive.
Yep. And if you wanted a second drive, you just bought another unit, but without the cartridge this time. Simple enough.
What about the discs themselves? They were those weird 3-inch ones, not the 3.5-inch that became standard.
Right, the Hitachi standard. And the capacity was actually pretty reasonable for the time, 180K per side. So you'd use one side, then pop it out, flip it over, and you'd get another 180K.
So 360K per disk in total.
Which wasn't bad. This was Amstrad using proprietary hardware to try and maximize storage efficiency while keeping the cost down. They really thought they had cracked the code on affordable, integrated CPM.
But the whole point of CPM, the core promise, was access to this massive library of established, powerful business applications.
Things like WordStar, DBase, the giants.
And this is where the entire system just imploded, thanks to something called the transient program area, the TPA.
This is the fatal flaw. It's a really crucial technical concept to understand early computers. The TPA is just the memory area that's available specifically for your application programs to run.
So it's the usable RAM after the operating system and everything else takes its share.
Exactly. Everything else, the OS, the BIOS, the buffers, sits outside the TPA. And to be fair, Amstrad's implementation of CPM was good. It had a true 80-column display, which was a big deal. Competitors like Commodore couldn't do that with their CPM.
So that was a big selling point. But the bad news.
The bad news, because of how the Amstrad machine was designed and configured, was that the TPA totaled only 39.5K.
39.5 kilobytes. That's it. That's all the space you have for any program you want to execute.
And that number, 39.5K, it was catastrophic.
Why? What did that actually mean in practice?
It meant that many of the standard, successful, industry-leading CPM programs, the very reason you bought a CPM system in the first place, things like the established versions of WordStar or DBase, they simply required more than 39.5K to load and run.
So you're saying you bought the operating system, you bought the expensive disk drive, you bought the whole business platform.
Yes.
Only to discover the actual tools you needed, the professional software, wouldn't fit in the machine's brain.
They just wouldn't fit. You were stuck.
So Amstrad, in trying to build this cheap integrated solution, accidentally created a completely proprietary, effectively incompatible dead end within the established CPM world.
That's the perfect way to put it. They created an island.
How long did it take people who just dropped, the modern equivalent of 1,500 pounds to realize this?
Not long at all. The second they tried to load the software they expected to work, they hit a brick wall. And the fallout for software suppliers was immediate.
What could they do?
If your program needed, say, 42K or 45K of TPA, you had two choices. You either fundamentally re-engineer the entire program to be smaller, which is a huge job, or you just ignore the Amstrad market completely, which is what most did.
And even if your program could fit, the logistics of converting it were brutal, weren't they?
Oh, yeah. You still had to persuade the software house to convert their programs to the specific Amstrad 3-inch disk format. It wasn't just a simple file transfer.
And the source material points out a really painful reality here.
It does. Since the Amstrad wasn't marketed in the U.S., where the vast majority of CPM business software came from, the conversion task would realistically only be undertaken by British software houses.
Which severely limited the available catalog of software.
It killed it. Amstrad had created an island operating system, totally incompatible with the established continent of applications.
So Msoft, realizing that the TPA was this major architectural crisis, had to pivot instantly. They had to try and build an entire application ecosystem from scratch just to make the hardware usable.
It was their only path to viability. They started commissioning specific conversions and new development. We saw that word processor, for example, from a company called Intelligence Ireland.
The one they priced at £49.95.
Right. And it was described as having WordStar quality, but crucially, it was engineered specifically to fit within that tiny 39.5K TPA limitation.
It also included a mini spreadsheet calculator for tables, and it was designed to integrate with their database and spreadsheet, all priced the same.
They were selling integration, but it was a forced integration. It was a workaround designed to overcome a fundamental technical flaw in the hardware.
And on the financial side, they brought in a company called Quest for the accounting suite.
Yep. The sales ledger, stock control, and invoicing bundled for that inflation-adjusted 400-pound package. They also had purchase and nominal ledger available separately for 33 pays each.
So Amsoft was basically building a complete parallel business offering.
Yeah.
But it required this huge investment just to achieve parity with what standard CPM machines already had.
It's remarkable how much effort went into bypassing one small memory constraint. But Amstrad wasn't purely business-focused. They were also trying to appeal to the home user, which led to this bizarre split personality for the machine.
Right, because they also commissioned games.
Yes, games and the Brainpower educational series from a company called TipTick. These were all available on disk, which was a huge speed upgrade over tape.
Right.
But the games did not run under CPM. They ran native.
So you had this dual identity machine, a business CPM machine that was crippled by its PPA, and a home machine running totally separate, dedicated software. It's so strange.
It's a mess.
And before we move on, we have to talk about the user experience, quirks, the commands.
Oh, yes. To be fair, Amstrad did implement legacy compatibility, which was smart. If you were an existing tape user, commands like ccat were automatically redirected to the disk when the cartridge was installed.
That was a thoughtful piece of engineering, helping users transition from tape. But to access the new disk-specific operations within BASIC, you had to precede the command with the bar symbol.
And this is the part that just makes me smile.
How did you type the bar symbol on the Amstrad?
You had to press Shift and at that.
Shift that symbol.
Yes. Shift at symbol. Yeah. Imagine having to preface every new powerful disk command with that awkward two-key combination. It just speaks volumes about the early compromises in keyboard mapping and UI design.
And one of those special commands was tape E, which just reverted the system back to cassette mode.
It's a wonderful artifact of a time when everything felt bolted together, including the commands themselves.
It's those little details, the 39.5K TPA, the shift at command, that remind you why standards had to be forged. And often those standards were forged in the heat of extremely expensive legal fire.
Which moves us neatly away from Amstrad and into the high-stakes battles raging in the professional market.
Now we shift to the two champions of that market, Apple and IBM.
And this era highlights two completely different kinds of pain, doesn't it? Apple was dealing with its own technological limitations and market confusion, while IBM was dealing with, well, direct corporate intellectual property theft.
Let's start with Apple and the Macintosh, the machine that was supposed to revolutionize everything. By early 1985, the unofficial word from Apple UK suggested a pretty significant problem.
Yeah, they were planning a special unveiling at their annual general meeting because, according to the sources, the company was desperately in need of a boost and short of cash.
That does not sound like a company on top of the world.
It sounds like a company in crisis mode. They were conducting this desperate, high-profile marketing push. They hired buses, staged these elaborate presentations around Hyde Park.
And they ran that legendary test drive concept where you could take a Mag home for the night.
They were trying so hard to project confidence.
But what did the market actually expect? What did people want from this big announcement?
They expected solutions to the Mac's fundamental problems. They wanted a network, a file server, maybe a price cut. But more than anything, they wanted a speed boost.
And what they got was a reality check.
A huge reality check. The Macintosh, even the new 512K machine, was, again quoting the source, dreadfully slow.
Yeah.
The graphical interface, the mouse, the whole Macness of it was wonderful, but the performance just killed productivity.
And the anecdote here is unforgettable. The source notes, you could make a cup of coffee between deciding to stop McPaint and starting McWrite.
That's not a graphical revolution. That is a graphical drag.
And this brings us right back to the sticker shock. To make the Mac usable for professional tasks, you often had to buy an external hard disk.
Right. And the specific unit that our source tested from a company called Small Systems Engineering cost a staggering £5,000 in 1985.
So let's do the math on that. We're talking about an additional piece of hardware just for storage.
That costs the equivalent of £20,000 today. £20,000.
£20,000 strapped onto the Mac's AppleBus port just to achieve a basic level of usable speed.
And here's the kicker. Even with that £20,000 hard drive, the machine was still lethargic.
What's the specific metric they gave?
It's painful to read. It took 20 seconds just to close one text file, find another one, and open it.
20 seconds. For a basic file operation, imagine sitting in a business meeting, trying to pull up documents, and you're just waiting for 20 seconds between every single file.
It was crippling.
Yeah.
It was completely unusable in a fast-paced professional environment.
That glacial speed seems like an existential threat to the whole Mac concept. Was it just a hardware limitation, or was there something else going on? Was there a design philosophy that traded speed for something else?
It was a trade-off, and it really highlights the Mac's sophisticated and maybe overly ambitious architecture.
How so?
The machine stored significantly more data than other micros at the time. This was because of two things: the detailed graphics and the pretty typefaces, which required a ton of processing.
And the second thing?
And its robust file integrity system.
Robust file integrity, what does that mean?
The Mac was engineered for maximum file safety. Every time it saved a permanent file copy to the disk, it went to great lengths to know exactly how far it has gone in that save process.
Okay.
So if the power was suddenly cut, the system was designed to pick up all those complex hanging threads and weave the file back together perfectly when the power came back on.
So it was speed sacrificed for peace of mind and for graphical sophistication.
That's it, exactly. An elegant technical solution for sure, but when you're aggressively targeting a business audience that needs speed and efficiency above all
It's
else.
the definition of misreading your market, isn't it?
Yeah.
Or maybe the graphical OS was just impossible to run any faster on the hardware of the day.
Probably the latter.
Yeah.
The graphical OS was so resource intensive that this was the best they could do with the 68,000 processor and the limited memory they had. The source noted that something had to be done to speed things up.
What were the suggestions?
A truly fast hard disk, or even better, a chunk of semiconductor memory pretending to be a disk, which would run hundreds of times faster than a floppy.
A RAM disk.
A RAM disk, yeah. And the source mentioned that hints of this faster storage were expected, but crucially, not for some months.
And that delay, the inability to deliver the necessary speed, quickly created this massive vulnerability for Apple.
It did. And they were also suffering from these confusing copy protection issues. Apple's official rule for software was that you had to have the original disk in the machine.
But you could run the software from a copy on your hard drive.
Right. It was designed to deter casual copying while still letting users, use their expensive hard drives.
But that policy immediately created software conflicts.
Of course it did. Programs like PFS File and Report and Macintosh Pascal, they just wouldn't operate under that specific rule, which meant users couldn't use their 20,000-pound hard drives with critical business applications.
It was just another example of a high-minded policy completely failing when it hit the messy reality of application development.
So we shift now from Apple's self-inflicted wounds to the corporate juggernaut that was IBM, engaged in the pure Wild West of the Clone Wars.
This is where the legal system basically defined computer compatibility forever.
And the battleground was a machine called the Advance 86, an IBM PC imitation being sold by, of all places, W.H. Smith's new computer shop chain.
The speed and the price of this clone threatened IBM's dominance, and IBM reacted instantly.
Their lawyers immediately wrote to W.H. Smith, to Ferranti, who built the machine, and to the Advance company itself, and they issued this famous, incredibly blunt warning. Just stop it. This wasn't a polite request for negotiation. It wasn't a let's talk. It was a clear declaration of war.
And the cause of the dispute was incredibly specific and technical. It was all about the ROM chip.
The ROM chip containing the basic input-output routines, the BIOS. IBM claimed that the Advance 86's ROM was 90% identical to its own.
But here's the critical piece of evidence. The thing that defined the entire conflict. The ultimate smoking gun.
And it's brilliant from a legal perspective. The Advance 86 ROM didn't just imitate the code.
It reproduced the known errors in IBM's original BIOS software, identically.
Wait, so IBM wasn't just claiming infringement on their proprietary code. They were arguing that copying their mistakes proved they hadn't bothered to write their own code.
That's the genius of it. IBM was essentially saying, look, if you had reverse engineered this legitimately, you would have fixed our bugs. Since your code includes our bugs, you just copied our copyrighted code wholesale.
And IBM's stance, consistent with previous disputes against companies like Eagle and Corona, was that the BIOS ROM was protected by copyright and patent. This was the battle for the core operating DNA of the PC.
The stakes here were the entire future of the PC market. If you wanted to build a compatible clone, you couldn't just copy the BIOS.
No, you had to legally reverse engineer it through what's called the clean room process.
I'll explain that.
One team of engineers reverse documents the functionality of the original BIOS, what it does, not how it does it. Then a second, completely isolated team writes entirely new code based only on that documentation without ever seeing the original IBM code.
It's a legal firewall.
Exactly. And our sources mentioned the outcome was really uncertain for W.H. Smith in Advance. They were hoping for a deal like the one IBM struck with Corona earlier that February, which let Corona keep operating.
But they also feared the outcome that Eagle experienced.
And this is the critical distinction that solidified the legal framework for the clone market. The Corona deal happened because Corona agreed to implement a legally clean BIOS. They survived because they complied.
So the fear for W.H. Smith in Advance was that IBM could just drag them through court and force a total collapse, just like what happened to Eagle in the U.S.
Yes. And the skeptics in 1985 were particularly wary because Producing a genuinely new, clean ROM inside 3 weeks, which was the immediate pressure they were under, seemed highly improbable.
The pressure wasn't about fines. It was about market extinction if you couldn't get a compliant product to market almost instantly.
This whole period established the necessity of the clean room BIOS and defined the boundaries of intellectual property in the PC world. The legal struggles of 1985 secured the dominance of the MS-DOS architecture by forcing every competitor to conform to these very specific and very expensive legal standards if they wanted to be compatible.
That struggle over the underlying BIOS code provides a fantastic bridge to the layer above it, the user interface and the application layer.
Right. The fight for the hardware DNA was one thing, but the true user experience was being shaped by the battle for the desktop and for applications.
And that desktop battle was primarily waged between two companies, Microsoft and Digital Research.
Or DocR. And our sources highlight this fascinating rivalry that was driven by impeccable timing. Microsoft, the author of MS-DOS, always seemed to make a major announcement right on the heels of DocR, the author of Concurrent DOS, releasing something new.
It was this continuous corporate one-upmanship. A great example. When DocR released details of GM, their graphics environment manager Microsoft immediately countered by announcing MSNet.
Which was their system for linking MS-DOS machines together.
But GM itself was a significant step toward the GUI future we live in now. It was shown at the PCW show, and importantly, it made Acorn's new ABC range of computers look strikingly like a Macintosh.
And this was a critical moment. This is where the IBM-compatible world really started moving toward a graphical environment.
But just like with the Mac, the speed question immediately came up with G. The fear was that these ease-of-use features often consume a lot of memory and processing time.
They take time to load, and then they often require reloading after the application is finished. And we saw this frustration play out on machines like the Apricot and the HP 150.
Where these so-called friendly interfaces drove business users crazy because data was just cranking slowly in and out.
The promise of the GUI was simplicity, but the reality for many was just performance degradation.
And Microsoft's countermove was aggressive on multiple fronts. Announcing MSNet was a shot across DR's bow, and it was significant because it marked the first time Microsoft had announced a major infrastructure initiative before IBM did.
They were stepping out of IBM's shadow, but the real thunderstellar was Windows.
Right. MS Windows, which they had announced the previous year, was now expected to ship in April 1985.
And that timing was perfect. It was clearly designed to intentionally steal DR's thunder on windowing capabilities, which were central to DR's whole pitch for concurrent DOS. Microsoft was playing the long game, betting that their windowing environment would win out, even if it arrived a bit later than GM.
The OS and GI wars were only half the story, though. We also have the messy saga of Lotus Symphony.
Oh, the integrated application suite that caused this massive wave of buyer's remorse.
Lotus offered a really generous upgrade path. You could send in your old 123 disk, and you could upgrade to Symphony for just $200.
And this was supposed to be the ultimate integrated package, right? Spreadsheet, word processor, database communications, all in one. But the critics suggested that the number of people asking for their old 123 disks back was significant.
Some claimed Lotus received thousands of requests to downgrade.
They did.
Why the immediate and intense backlash? If it was this great integrated upgrade from the industry standard, why did people want the old version back so badly?
There were two key reasons, and they both reflect this complexity trap of the era. First, some users just found Symphony too complex and unwieldy. It was a common pitfall of early integrated suites.
And the second reason?
The second, and this was the critical one for established business users, was that Symphony often wouldn't accept their very biggest, most complex 123 spreadsheet templates.
Ah. So the new architecture sacrificed compatibility with the large, established, mission-critical spreadsheets that users relied on every single day.
That's a huge failure to respect your legacy user base.
Absolutely. Mitch Kapoor, the head of Lotus, had to immediately address this backlash. He suggested that, time and practice would solve the complexity problem for the minority who complained.
But for the template size issue, the technical constraint was real. He couldn't just wish that away.
So how did they plan to fix the fact that you couldn't load your most important files?
They planned to launch a new software tool that would give Symphony users more memory inside the IBM PC.
So they were trying to fix an application's architectural problem, the way Symphony managed memory, with an external hardware and software patch.
It just highlights the desperate lengths developers had to go to squeeze every last bit of functionality out of the 640K limit of the IBM PC.
What's fascinating, though, is that Kapoor recognized the need to abandon the DOS approach entirely when he looked at the competition. The biggest Lotus announcement on the horizon wasn't another DOS product.
No, it was a Macintosh version. And this Mac version was explicitly not going to be Symphony or 123. It was going to be a completely different product.
Engineered from the ground up for the Mac environment, using separate data structures, automatic cut and paste.
It showed Kapoor's realization that the Mac environment fundamentally required a different application architecture than the linear, memory-constrained DOS platform.
Moving from the spreadsheet wars to the pioneers, we have the strange case of VisiCorp's rebirth into Paladin.
This is a great story. VisiCorp, originally a company called Personal Software, was the company that had invented and then lost the rights to VisiCalc, the first killer app.
They were the pioneers who completely missed the transition to the professional desktop. Their next-gen product, the Vision environment, was complex, expensive, and it just failed to gain traction.
And the result was that the larger, troubled VisiCorp was essentially swallowed up in a reverse takeover by the smaller Paladin Software Corporation. The dynamic, smaller company absorbed its once giant but failing predecessor.
And Paladin immediately focused on new products aimed at market viability. They planned an IBM version of FlashCalc, which sold well to Apple users, and applications for the Vision environment, including PC Paint graphics.
They also expected Vision prices to drop sharply. They were trying to pivot Vision from an expensive, all-in-one suite to a broader, more accessible environment.
But the real competition in this desktop utility space came from the original VisiCalc inventors, a company called Software Arts.
Yes. They came up with a successor called Spotlight, which was essentially a system manager. It gave you an on-screen calculator, a phone book, an index card file, and a notepad.
And this product offered a direct, powerful contrast to the Macintosh philosophy we were just talking about.
Absolutely. Spotlight's massive market-defining advantage was that it runs in the background with nearly every program available for the IBM PC, XT, or Compaq.
That was crucial.
It was everything. You could be running WordStar, and you could instantly pop up the calculator or the address book without having to close down or swap disks.
Which directly addressed the Mac drawback, where you couldn't even look at another document without that huge 20-second application switch.
Spotlight was providing genuine, usable multitasking and background utility functions that business users desperately needed, a level of efficiency that Apple, with its single application-focused architecture, was really struggling to deliver.
And that's why the DOS platform, for all its ugliness, continued to thrive in business. It allowed users to hack together functional, fast systems using tools like Spotlight.
That whole discussion about what runs in the background leads us neatly into the broader context of the industry. The struggle for standards wasn't limited to the desktop or the legal battlefield of the BIOS. We need to zoom out a bit and look at the market shifts happening in professional servers and the home sector.
You have this constant push for a robust multi-user standard, which was really evident in the Unix market. Unix System V was emerging as the key standard for servers and larger business machines.
But it had one massive, critical weakness.
A notorious lack of application software.
Exactly. And this is where we see companies actively trying to buy a standard. NCR recognized the application shortage, and they teamed up with Unix Europe Ltd. To solve the problem through financial incentives.
Directed at independent software vendors.
The incentive package was aggressive. Vendors were offered a 30% discount on the NCR Tower, which was the company's server platform, and this was a machine that had an entry price starting at £10,000.
So a huge discount. That wasn't all, was it?
No. Not only that, they received a completely free copy of Unix System V.
So an independent software developer could get a server platform and the operating system for substantially less than retail cost, simply for agreeing to port their applications over.
Precisely. This was a deliberate market strategy to fuel the growth of Unix as a standard. NCR hoped that just as PC-DOS had become the standard through the sheer quantity of available software, their subsidized program would create the same groundswell for Unix System V.
It shows how the battle shifted from building the best technology to simply ensuring you had the widest breadth of application support.
Meanwhile, you have this very intriguing attempt to crack the professional market coming from Europe. The French invasion, led by a company called SMT.
The maker of the Google Micro. Goupil means fox, which is a fitting name for a clever attempt to sneak into this crowded market.
SMT opened offices in East Putney with a hyper-specific strategy. They wanted to target the Anglo-Saxon market, which they defined as the UK, South Africa, America, and French-speaking Canada.
And their hardware approach was pretty unique for the time. The Goupil Micro was based on the Motorola 6809 processor, an 8-bit chip.
But it had add-in options for the 8088 and the Z80 chips. It was a technical Frankenstein, but it offered extreme flexibility.
It was a chameleon. By having those 3 different chips, the Goupil could run programs written for CPM using the Z80.
MS-DOS using the 8088 or its own native system on the 6809. This multi-standard capability was exactly why it was so successful at home in France.
And their success there was undeniable. The Goupil was the country's 3rd bestseller. It gained significant sales from government, defense, and education sectors.
And that success was deeply political. Our sources note that this market traction was often attributed to strong anti-American sentiment.
So government educational institutions were choosing this domestically successful, technically flexible system over purchasing IBM or Apple hardware.
It seems so. And the UK head of SMT was clear-eyed about the challenge of entering the fiercely competitive British market. He said he was prepared to take 2 years without operating profit just to establish the company.
That signals an intense long-term commitment to trying to break that US-UK duopoly.
Shifting dramatically from corporate servers and French patriotism, we have this cold, hard look at the domestic side of the market. While the business sector was thriving, a market assessment publications report predicted a major home market correction.
This report was controversial. It was expected to draw rage and flack from Commodore, who were, heavily invested in the home market boom.
And it predicted that the UK home computer market would fall dramatically, from a peak of 1.9 million units per year down to just 1.2 million by 1988.
This was a prediction that the initial novelty of home computing had just worn off. The report argued the market would shift away from pure games and novelty and pivot toward domestic management and home workstation applications.
The average user needed a serious practical use case beyond just entertainment to keep buying these things.
But despite that looming correction, the market shares in the UK remained relatively stable at this point. Sinclair was the undisputed leader with 43%, followed by Commodore at 22% and Acorn at 10%. However, the report highlighted the market's extreme vulnerability. With around 38 brands all fighting for space, many lacking public awareness, the report called tragedy inevitable.
Yeah, the smaller, less powerful machines looked incredibly vulnerable, especially if MSX, the emerging Japanese standard for home computing, gained any significant popularity. It was a clear forecast of consolidation and collapse.
It's a stark reminder of how many different standards were competing at every single level of the market.
And we finish this section by looking at some of the small, critical battles and technical quirks that plagued users on a day-to-day basis. These really highlight the sheer messiness of non-standard development.
One of the best examples is the Elite RAM conflict on the popular BBC Micro.
Ah, yes. Elite, the groundbreaking, hugely popular game, used memory areas that clashed with third-party disk filing system software, specifically Opus DDoS and Microware's DDFS.
And the result was intermittent but catastrophic system crashes. You bought the game, you bought the disk drive, and they literally fought over the machine's memory.
So what was the response from the manufacturers?
Initially, Acorn Soft and the disk software houses were completely unhelpful. They adopted that not our problem stance, which our source notes was very much in the Acorn tradition of high-handedness.
Which left users with a choice between using their disk drive utility or playing their favorite game.
That's a terrible user experience.
Right.
But this small conflict, this really niche compatibility issue, eventually forced cooperation.
It did. Opus eventually produced a modified interface to ensure compatibility, and Microwares fixed it in version 2.0 of their DDFS. This microcosm just shows that even technical disputes over a few kilobytes of RAM could define user satisfaction and ultimately force companies to cooperate to create de facto standards.
We also saw key infrastructure and legality finally catching up with technology in 1985. We get the update on legal modems.
Approval was finally granted for the Minor Miracles modem, which worked to just about every communications standard in the world.
And the hilarious irony is that thousands of people had already been using this modem illegally, plugged into their new style BT sockets.
Because the demand for advanced connectivity and high-speed communication massively outpaced the slow-moving regulatory approval. Users were basically performing civil disobedience for the sake of dial-up.
And the multitasking legal wrangles continued with multi-job for the IBM PC. This product from B&L Software, which allowed for multitasking.
It was finally authorized and sold by Impex Software for £100, following a history of illegal copies, which inevitably crashed the system because they lacked proper support and licensing.
These little stories just highlight that tension between cutting-edge, complex functionality like multitasking and global modems and the slow machinery of legal authorization and market maturity.
And let's not overlook the fun, inventive hardware that was trying to do everything at once, like the Penman robot plotter.
Right, for 217 plus VAT, this thing combined a plotter, a printer, a turtle, a robot, and a mouse.
That is the ultimate multifunctionality dream of 1985. It connected to virtually any computer which has an RS-232 interface, with specific applications available for the Apple II, the BBC, and IBM PC business packages. It was this ambitious attempt to provide every possible peripheral function in a single device before dedicated standardized peripherals took over.
And finally, the Philips Portable, the P2000C, saw an update that perfectly encapsulates this chaotic standards environment.
It was now available with an 8888 board. This enabled it to run MS-DOS 16-bit applications alongside its original 8-bit CPM and P-System software, all starting at $995.
A single portable machine running 3 entirely different operating systems.
That is a legacy we will hopefully never return to. The Philips P2000C was a technological lifeboat, just trying to keep up with every standard shift simultaneously.
What a journey through the chaos of 1985. I mean, from the 20,000-pound hard drive for a sluggish Mac to Amstrad's fatal 39.5K memory limit. It's time to connect the dots and establish the lasting legacy of all this for the listener.
I think the central lesson is that the computing standards we all rely on today, the ones we take for granted, they were not born from elegant engineering consensus.
Not at all.
They were forced into existence through market warfare, through technological compromises, and through expensive, messy legal precedent. The sheer chaos of 1985 was the crucible that forged them.
We saw technological compromise just completely define viability. Amstrad's attempt at a cheap CPM standard was killed by that one limitation, the transient program area being just 39.5K.
And that limitation immediately destroyed its compatibility with all the established CPM software, forcing Amsoft to try and rebuild an entire application ecosystem from the ground up, which was an impossible task.
Then we saw legal battles defining hardware standards. IBM's lawsuits against the clone makers weren't just about code similarity.
No, they were about the reproduction of known errors in the BIOS, and that established that the intellectual property of the core input-output routines was the key legal battlefield.
Which forced the expensive cleanroom engineering process and cemented the dominance of the MS-DOS PC architecture.
And we saw application rivalries shaping the user experience. The fight between Digital Research's GM and Microsoft's MS Windows, coupled with that functional backlash against complex integrated software like Lotus Symphony.
It highlighted that ease-of-use features often slowed down performance to a crawl.
Which created an opening for solutions like Spotlight, which ran in the background to overcome the Mac's file access drawbacks, and gave the ugly but functional DOS platform a huge business advantage.
And seriously, the performance contrast is the most salient point to hold on to. We complain about a slow refresh rate today.
But the source had to wait 20 seconds to close one text file and open another on a Mac, even after strapping a 20,000-pound hard drive to it. The fundamental limitations of 1985 were just crippling.
So, if the IBM clone wars centered on the BIOS and cemented the PC standard, what about the competition that was supposed to keep the PC honest? We talked about the entrenched system that was facing massive pressure, the Apple II family.
Right. The Apple II was everywhere. It was widely used in homes and schools, and its lifeline for the 16-bit future was slated to be a new chip, the 65816.
This was a hugely anticipated upgrade.
It was. The 65816 was a 16-bit chip with an 8-bit data bus. It was designed to give the Apple II an extra couple of years of life by handling up to 312K of memory.
Which would significantly extend its capabilities far beyond the 64K limit of the old 6502 processor. It was the technological bridge Apple desperately needed to survive the mid-80s transition.
But here's the final provocative thought for you to consider. the critical detail that may have determined the fate of that standard.
Okay.
This new chip, the 65816, was not expected to appear for another 18 months after this 1985 news cycle.
18 months, an eternity in technology years.
Exactly. The battle for the 16-bit desktop was clearly the future, but Apple's technological lifeline for its huge entrenched home system was stuck 18 months out.
So the final question is,
What effect did that long, agonizing delay have on the rapid, aggressive rise of the IBM PC and its clones? Did that 18-month gap give the PC architecture an unchallenged window to consolidate its standard in the corporate home and educational markets, allowing them to define the future without meaningful competition from the Apple II family during that most critical period of market transition?
a delay in one tiny chip and the world changes. Thank you for diving deep with us. We'll see you next time.